Hey everyone, in this video we're going to convert the floor to a React fiber. Now the floor is kind of special because it's just a plane covering the entire screen, but it is behind all the objects in the scene. And besides that, it's also possible to change the floor colors. So if you would go there, you can give it any color you want. And we're going to completely add all those functionalities as well. And how that will look in the end is like this. We are going to use a different debug panel, but the functionality is going to be exactly the same. And we're going to do that by converting this floor class with quite a lot of code to a floor component, which is looking a lot cleaner. It only contains a plane with a custom floor material that we're going to convert ourselves as well. And the floor material will be a class which contains some of the logic to generate the colors. So yeah, let's dive into that. So let's go back to where we left last time. We created a folio canvas with a React fiber canvas in there. And we set some configuration there so that the application now has the correct colors. It behaves completely as you would expect, and it looks the same as Bruno Simon's own project. We also created this folio React fiber component, which currently basically only has three.js code inside of it and returns null, which means that we don't make use of React fiber components in here yet. But that's going to change in this video, because we are going to convert some of the three.js code in here to React fiber and return that right here as a component, as you would expect in React fiber. And specifically in this video, we're going to look into the setWorld function, which basically only instantiates a new world and then adds that to the scene. Now I shortly mentioned it before, but this world class kind of bundles most of the application together. And in the end, it's responsible for adding all the different objects to the scene, including the floor, and it will add the sounds as well. But for this video, we're going to look into the setFloor function of the world class. And in there, we see something similar. It's only instantiating a new floor and adds that to the container of this world class. Now, if you look into the floor class, you'll see that it contains quite a big constructor where we set the colors, for example, of the corners of the floor, and where we set a material. This is a custom material that Bruno made. This is not provided by three.js. So if we would go there, you'll see that it actually returns a shader material with a custom shader that Bruno created. And therefore he has a fragment shader and a vertex shader, which we're going to look into soon as well. And after the instantiation of the material, we instantiate a update material function. And in this function, we are specifying the colors of the floor, which is basically the corners of the screen. So by default, that will be an orange color. And this needs to be a function because it's possible to change this color. If it wouldn't be possible to change the color, then we could just execute this code once right here. But in this case, it needs to be a function. And we can change the colors by going to the #debug URL. And opening the floor folder, and then here you have the option to change colors to whatever you want, and that creates a completely different look of the website. Now the way this is being done is the colors are instantiated here, and then we set a data array which is based on the RGB and alpha value of the different corners. Now the alpha value always needs to be 255, which means that it's fully opaque because we don't want a transparent background. The next thing we have is the background texture, which is being set based on that data that we have here. And it's set to the RGBA format so that it reads this data correctly, so that it knows that the first element will be a red value, the second one will be a green value, and so on. Then we set the Mac filter right here to linear filter, which is needed to have a smooth transition from one color to the other. Because if we wouldn't have this linear filter and we would set it to the default, you'll see that it just uses the default colors and it doesn't gradually change. It just changes from that one color to the other. So we'll need that filter as well. And then at the end, we set the T background uniform to the data texture that we created right here. And that's everything that happens in the update material function. And that update material function needs to be called right away to set the default orange colors. And at the end of this class, inside of the constructor, we are instantiating a new mesh based on the geometry, which is a default plane that covers the entire screen, and the material. And then last of all, we have the debug if statement, which only gets executed when you are in the #debug mode. And in there, we are adding a few values to the debug panel for the floor. And every time that value gets changed, the update material function is called. And therefore, you can see those live updates right here. Now, the way we are going to change this floor class to a React Fiber component is by creating a new file called floor component.tsx, which is basically going to replace this floor class piece by piece. So let's start with creating a React functional component and let it return null for now. Then if we would go to the world class, we need to have a React component for this class as well. We're not going to convert this entire class. We're just going to create a separate one. So I'll call that world component.tsx. And we'll do the same here. Now the world will, in this case, return the floor component that we just created. This world component will slowly start to have more and more content. And at the end, it will contain all the content that's currently in the world class that you'll see in the index file. But we're going to start with the floor only. Now, currently we are still instantiating that new floor class, and we'll keep it that way. But in the end, we're going to remove this set floor function completely. We need to do one more thing, and that is that in the folio component, we are currently returning null, and we're going to change that with returning the world component. So now basically we are instantiating that new world class above, and we are returning the world component, which can be duplicate, but we're gonna make sure that that won't happen. So as soon as we completely migrated something to React Fiber inside of the world component, we're gonna remove it from the world class. All right, so let's save this file and let's go back to the floor class. And if you remember correctly, you notice that basically all that happens here is that it creates a new mesh with a specific geometry and a material, and everything else is related to that mesh. So basically what we are going to do in our floor component is going to be very similar. We are going to return a same kind of mesh, and in our case that's going to be a plane. This is provided by React Dre, which makes it a little bit easier. We can just specify that it's a plane. And inside of there, we want to specify the material. Now, this is a bit difficult because the material is a custom floor material, as I mentioned. So we cannot just do this because that won't work by default. With other materials, such as the mesh basic material, that would work because this is provided by 3.js. But now we have a custom one, and we need to set some configurations for that. And first of all, if we want to do so, we need to convert this floor material to a class, because currently if you go to that floor inside of the materials folder, we have that floor material. It is a function which returns a shader material class. Now, instead of this, we want to have a class available. So we're going to create a separate file. Call that floor material.ts because we're working with TypeScript now. And this is going to export a floor material class. Now, as you've seen, the function is returning a shader material. So we want this floor material to be a shader material as well. And the most easy way to do that is by extending the shader material. So now we have the floor material class available, but inside the floor component, TypeScript is still complaining that the floor material does not exist on type intrinsic elements. And therefore, I'll show you something inside of the R3F fiber documentation. If we would go to the using with TypeScript page and we scroll down a bit, you'll see the extend usage heading. And in there is mentioning that R3F fiber can also accept third-party elements and extend them into its internal catalog. And that's basically what we want to do. So what we're going to do is add a file next to our main.tsx file, and we're going to call that 3 elements. That will be a TypeScript file, and inside of there we're going to do the same as R3F fiber is showing right here. We're going to extend our floor material right here. We'll need to import that, and we'll need to import the extend from R3F fiber as well. Now, the documentation is also mentioning that the error will still be there, and that's also the case for us. If you would go there, the error is still there. And therefore, we can extend the 3 elements interface and add some custom element to that interface. So basically what we can do is copy over this piece of code. And we're going to change that custom element to our floor material right here. We'll have to do some imports. This custom element will be our floor material, which will be the type of floor material. Now, if we go back to our floor component, you'll see that it works. And not only that, we can also click on it. It will bring us right here. And then we can click here to go to the actual material. Now, currently the floor material won't do much because it's still empty. So let's start implementing that. If you go to the floor function that we had before, you'll see that it instantiates the shader material with some configuration. Now the wireframe false and transparent false configurations are actually defaults of the shader material, so they are not necessary. So I'll remove those to make it a bit more clear. So that means that we'll have to set the uniforms, the vertex shader, and the fragment shader properties of the shader material. And since we are extending that, we can just set that inside of the constructor. So first of all, we're going to have to call the constructor of the shader material. And in here, we can set the uniforms. I'm going to copy that over like this. And after that, we can set the fragment shader and the vertex shader, where we're going to have to import those from here. Now, if we import this, let's first rename this to fragment shader and vertex shader. You'll see that TypeScript is complaining. And that is because TypeScript cannot find the corresponding type declaration of this fragment.glsl file. And that is completely valid because TypeScript can know what kind of return type this is. So yeah, it needs to know that. We know that it needs to be a string because the fragment shader property of the shader material is also of type string. So we have to specify that somewhere. Now, let's do so inside of the shaders folder of the project. And we can do that by adding a declarations.d.ts file, where the D stands for the type declarations. And inside of that file, we can paste the following code. where all the modules that end on .glsl, so all the files that end on glsl, will return the following, and that is a value of type string, and that will be the default export. So the export will be any value of type string, whatever value that might be. This means that if you go back, TypeScript will now automatically recognize that type declaration file, and it will set the type of the fragment shader and the vertex shader to string. So we can now set the fragment shader and vertex shader of the shader material to those imports. Now, the shader material doesn't provide any properties for the top left color, for example, but we want those values in our floor material, so we're gonna have to add those for ourselves. So let's specify the top left color, which is gonna be of type color from three.js. Let's import that and set it to a new color by default. Now we also have to do that for the other three corners, like this, but those properties are private, and I did that on purpose because in the floor component we only need to set the properties. So we're gonna have a public setter called top left color, which accepts a string. So inside of the floor component we only have to specify the hexadecimal string value, and inside of this material we will handle the instantiation of the color. So in here we'll set the top left color to a new color based on that string, and don't forget to convert it from linear to sRGB. Now let me quickly do the same for the other three corners. There we go. Now if one of those properties gets set, we want the material to update automatically, and therefore we had that function available, but we will have to add that here as well. Now we don't have that inside of this class yet, so let's go to the floor in here and copy over this function. So let's start with all of this, and inside of the floor material we can create a private function called update uniforms, and let's paste our code in there. Now we don't need to instantiate those colors because we already have access to those in our class right here. So let's use those instead for all the cases right here. There we go. And let's fix all the other compile errors as well. Okay, there we go. Now we have a compiling floor material. Now we are currently not using this update uniforms, but every time that we set one of the colors, we need to perform or execute that logic. So let's add that to all of those setters. Now, if you would go to the localhost 3000, you'll see that we get a white screen. And we get an error in the console saying that the floor material is not part of the tree namespace, with the question if we didn't forget to extend it. Now we did actually extend it, but that code is not included in our source code because we never import this three elements file. So inside of our main.tsx, which is our entry point of the entire application, we'll have to import that. So let's do so here. Now if we save that, you'll see that the error is gone. But the floor that we're seeing currently is the floor from three.js, and we want to see the floor from React Fiber. So let's actually remove the floor from three.js by going to the index.js file in our world folder and remove the set floor function there, because we don't need to instantiate the three.js floor anymore now. Let's also remove the call to set floor in the constructor and save that. Now remember, we don't need this anymore because we now have the world component inside of our folio, and that world component now has a floor component. But as you see, currently the colors are not correct, or the floor doesn't show at all. And that is because we currently don't set the default colors of this floor material. So for example, here we now have the possibility to set the top left color. And if we would set that to a random color, let's make it red, for example, you'll see that now the floor actually shows up, but it is too small. We're still going to look into that as well. But let's first change the colors to the default colors of that Bruno used himself. And therefore we need to go to the floor and copy that over. And let's do the same for the other colors. And there we go. Now the colors are all correct. Now we still have that issue that the plane is too small, and that's quite easy to solve. So if we would go to the floor.js, then you'll see that Bruno created the geometry, the plane buffer geometry with a size of 2 by 2, with 10 width segments and 10 height segments. Now we don't need those width and height segments because it works fine with the default of 1 width and height segment. But we do need to set the width and height to 2, because we currently only set the width and height of the data texture to 2, but not of the actual plane. So if we would set the arguments right here to 2 and save that, you'll see that the screen is completely filled. Now there are 2 more important settings that Bruno added on the bottom of this floor.js file. And that is that he set frustum cult to false and he set matrix auto update to false. Now this frustum cult property will, if that's set to false, 3.js will not check on every frame if the plane needs to render. It will just always render this mesh. And that's what we want, because the floor will always be in the camera. So we don't have to check if it is in the camera or not. We can just always render this. So let's set our frustum cult to false as well, right here. Now we also set the matrix auto update to false, and that we can add that as well because we are not changing any of the position or rotation or whatever of this plane, so that's unnecessary. And that was everything we had to do to convert this floor.js to a React component. So now we have a fully working React Fiber version of this plane, which is awesome. But I want to mention one more thing about this, because if we go to the floor material right here, I promised that I would show or explain something about the fragment and vertex shader, because those are being used inside of the shader material. We need to specify our custom shaders here, which are programmed in GLSL. Now, if we would go there, what Bruno did here is he set the position based on the screen position instead of the 3D scene, because normally you calculate the position based on the view and the projection matrix, and you need to do some calculations for that. But in our case, we are just setting the position of the rendered pixel of the plane to, the only position that is passed. So we don't do any additional calculations there, which means that it will just start on the left top and go to the right and to the bottom. And it will always set the Z value to 1, which means that the depth doesn't change at all. And the alpha will always be set to 1 as well, so that it's fully opaque. And that's everything that's needed to get this to work. I think it's a pretty cool solution to get a floor to work inside of 3.js. I haven't used this myself, but I'm definitely going to use this as well. Now, one more thing that I shouldn't forget is that it's currently not possible to change the colors of the floor, while that was possible before. So if we would go to the floor component, currently those colors are hard-coded, but we're going to change that. And we're going to use leva for that. which we already have installed in this project because it was part of the base code. So we can right away start using the use controls hook. So let's say we have a top left color right here. We get that with the use control hook. And we can give that a default value. Let's set the default value to this. And change this right here with that actual value. Now if we would save that and refresh the page, you'll see that it now adds the top left color here. We also get a nice color picker and we can change that and it gets updated live right here, which is pretty awesome. Now let's do the same for the other colors. There we go. Now we have added all the colors and they are all working as you would expect. Cool. Now, because we're gonna add a lot more of debug possibilities, I'll add this to a folder. So right before we pass the object, let's first pass a string called floor, which will be the name of the folder, so that we can collapse it. And we can actually also pass a third argument and collapse it by default, which doesn't seem necessary right now, but once we have a lot of options, it's nice if everything is collapsed by default. So let's do that. And I'll also give it a color, which is gonna be an orange color, so that it's easy to distantiate the different folders that we're gonna have. Let's refresh the page once again. And there we go. Everything still works. Now I do want to mention that we currently have the debug panel in our normal localhost 3000, but Bruno only showed it when he went to hashtag debug. So we're gonna do that as well. We will add a different hashtag, hashtag leva, and only show this debug panel when we go there. And the way he did that, if we go to the application.js file, you can see that in the setConfig function, he's setting the debug based on the window.location.hash property. He's checking if that equals to hashtag debug. So inside of our app.tsx, we can add some configuration for leva by adding the leva component and closing that. And we can set the hidden property to a specific value. Let's say is leva debug, and let's set that value right here, and that can be based on hashtag leva instead of hashtag debug. And we actually want to hide it if it is not in debug mode, so we had to add the exclamation mark there. Now, because there are going to be such a lot of properties, let's also add a collapsed true, so it's collapsed by default. And to make those labels a little bit more readable, let's also add the one line labels property and set that to true by just specifying it. We can actually do that here as well. Now if we save that, you'll see that the debug panel is gone now. But if we go to hashtag leva, you'll see that it's there and it's collapsed by default. The floor folder is collapsed as well, and now everything is more easy to read. Awesome. And that was actually everything about the floor. So congratulations, you now know how to convert a real 3.js content class to React Fiber. You also know how to create your own custom material, which even uses a custom shader. It's a bit unfortunate that I don't have the time to go into detail about all the shaders that Bruno created, but that's a whole different topic that I'm gonna leave out of this course. Maybe I'll make more videos about that in the future. Yeah, we even used some leva code for debugging. You might have learned something new there as well. And yeah, that means that we can now safely remove the floor.js but I know that we still need to remove the import here, some inside information. So let's remove that from the index file, save that, and now if you remove the floor.js, the website will still completely work with our own React Fiber floor. I hope you enjoyed the video. I'll see you next time. In the next video, we're going to clean up some unnecessary code, unnecessary files from Bruno, which are actually also causing some conflicts for our ESLint and Prettier. So it's going to be a bit of a shorter video. See you there.